This video is intended only on determining whether this given equation is an exact differential equation or not. We will have a separate video pertaining on the solution itself. But of course, the processes involved in solving this equation will depend on whether this is an exact or non-exact differential equation, because we have two different methods for that. To determine whether this is an exact differential equation or not, we need to establish this certain equation. We have the partial derivative of m with respect to y must be equal to the partial derivative of n with respect to x. In order for us to do that, we need to establish or identify the function m and function n. This equation can be expressed in this order or in this manner: m of xy dx plus n of xy dy equal to 0. This would mean that our function m is the function paired with dx, and that's actually this here. You have 5x plus 4y. Similarly, our n of xy is the function paired with dy, and that would be this function. You have 4x minus 8y cubed. This time, let's try to take the first partial derivative of m with respect to y, and of course later the partial derivative of n with respect to x. Before we do that, let's try to remember that this is only on partial derivative. Take note that there are two variables on our given function, both for m and n. Okay, but if we take the partial derivative of m with respect to y, we are going to integrate it, or get its derivative with respect to y. This would mean that the other variable, that's x, will be taken as a constant. In short, 5x is a constant now. And the first derivative of a constant pertaining to 5x is just equal to 0. Plus the first partial derivative of 4y. Now y is a variable, so we are going to have here 4. This would mean that this answer is just equal to 4. Now for the partial derivative of n with respect to x, since we are just getting the derivative with respect to x, the term with variable y, or the variable y, will be taken as a constant. This would mean 8y cubed is now considered as a constant, and its first order derivative is just equal to 0. Specifically here, minus 0, because that's minus 8y cubed. And the first order derivative of 4x, as we are taking it in terms or with respect to x, is just equal to 4. So the partial order derivative of n with respect to x is also 4. We can see here that the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x, because they are both equal to 4. This would mean that our given equation is an exact differential equation, because we have established this equivalence. And we'll be using the method of solving exact differential equations for this specific item, and we'll have that on a separate video. Thank you very much for watching.